Okay, Common Core Algebra 1. So last couple weeks we have spent talking about the properties of exponents and how they behave algebraically with each other. Now the next couple of videos are going to be about graphing exponential functions. So we're still going to need to be aware of a lot of those properties and how they behave, and then we will see how our exponential functions look at a graph. So far this year we've graphed lines and we've graphed quadratics, which we call parabolas, and now we're going to look at what is called an exponential function. So we'll have two basic types, one, and they look very similar, they're just a reflection of each other basically. One is going to be growth, one is going to be decay, and then also today we are going to talk about evaluating with the table. So this one is the biggest piece for today. The next video really is going to get into what growth and decay look like and how we actually graph the function. And so to start then we need to know an exponential function, what it looks like. And it's going to be any function of the form y equals bx. So you notice now your variable is the exponent. That is the big piece. Your variable is in your exponent. Okay, b is never going to be equal to 1, and it's always going to be positive. So it's any number between 0 and infinity. Never a negative number, never 0, and also never 1. Okay, the domain then, much like quadratics and parabolas, is going to be all real numbers. So if I ever asked you for any of the domain of these, you could easily always identify it as all real numbers, meaning any value of x can be plugged in and we would get a y value out. And examples would look something like this. So we could have y equals 3 to the x, or remember this is called function notation, so we'll see this a fair amount of times, just like we did last chapter. F of x equals 7.2 to the x. Again, our variable here is x. And you notice in both cases, b is positive and greater than 1. Okay, so like we said, we're going to have two types, the growth and decay. Now growth means when we have that b value is greater than 1. Okay, so not just greater than 0, it's also going to be greater than 1 like the last two examples we saw, or also right here, your b value is greater than 1. Okay, decay then is going to happen when b is in between 0 and 1. So b is less than 1, but remember it also still has to be greater than 0, so it could be numbers like 1/2, 2/3, or 0.5, and then to our variable x. Remember again, f of x here is just the same thing as saying y. Okay, these are really interchangeable for this piece. Evaluating when we have a table of values, then we're going to have some example function, and what we're going to do is just take our x to create a table. So you're going to choose values of x. You may not be given them, you may be given them. Either way, you're going to create the table using your values of x, plug them in, and if it is a growth equation, again meaning b is greater than 1, sorry that should say 1, the number should increase rapidly. If it is a decay equation, meaning 0, or b is in between 0 and 1, then the number should decrease rapidly. So an example of that here, f of x equals 2.5 to the x. So here b is greater than 1, and we can see that b is equal to 2.5. So our numbers here, when we plug it in, we've got our x values, -1, 0, 1, 2, and 3. Our f of x values should get increasing pretty quickly. So if we plug in -1, we're going to get 0.4. If we plug in 0, we're going to get 1, and this should always actually happen. Anytime you raise a number to the 0 power, remember, you're going to get 1. If we plug in 1, we get 2.5, so you see we're increasing a little bit, starting to increase quickly. 2, 6.25, so that's a big jump, and then 3, 15.625. So we could then, next video we'll talk about this, take these as coordinates and plot them as points and see what our graph looks like. Again, this would be a growth equation because b is greater than 1. And that is it for this video. The next one, like we said, we will talk more in depth about graphing. This was really the big piece, how to evaluate with the table and knowing the difference between growth and decay. All right, see you next time.